Hey there, explorers. Have you ever wondered what's really going on in the Bermuda Triangle? You know, that mysterious patch of ocean where ships and planes seem to vanish into thin air? It's a place that's sparked countless stories, from alien abductions to sea monsters swallowing ships whole. But today, we're not just chasing ghost stories, we're diving into the science behind this legendary enigma. Buckle up, because we're about to separate fact from fiction, uncover some jaw-dropping theories, and maybe even solve a few mysteries along the way. Let's set sail. Picture this: a vast stretch of ocean, roughly 500,000 to 100,000 square miles, depending on who you ask, connecting 3 points: Miami, Bermuda, and San Juan, Puerto Rico. This is the Bermuda Triangle, sometimes called the Devil's Triangle, a name that sends shivers down the spine. It's not just a random patch of water, it's a region steeped in history, mystery, and a whole lot of intrigue. Let's go back to the beginning. The Bermuda Triangle first grabbed the world's attention in the mid-20th century, but stories of strange happenings in this area date back much further. Sailors in the 1800s whispered about compasses going haywire and ships disappearing without a trace. One of the earliest recorded incidents involves the USS Cyclops, a massive Navy cargo ship that vanished in 1918 with over 300 crew members on board. No wreckage, no distress signal, just gone. Can you imagine the panic? A ship that size, poof, into thin air? Then there's the infamous Flight 19, a group of 5 Navy bombers that took off from Florida in 1945 on a routine training mission. The pilots were experienced, the weather was clear, but something went terribly wrong. Radio transmissions captured their confusion. We are entering white water. Everything looks strange, even the ocean. And then, silence. A rescue plane sent to find them also disappeared. 13 crew members, 6 planes, all lost in the Bermuda Triangle. These stories fueled early theories that were, let's be honest, pretty wild. Some folks believed the triangle was a portal to another dimension. Others thought it was cursed by ancient spirits, or even guarded by a giant sea creature. The media didn't help, hyping up every disappearance with headlines like "The Sea That Swallows Ships." But before we get carried away with krakens and UFOs, let's take a step back and ask, what's the real story here? Okay, let's address the elephant in the room, or rather, the alien in the triangle. The Bermuda Triangle has been a breeding ground for some of the wildest conspiracy theories out there. Alien abductions? Check. Time warps? Check. Even Atlantis, the lost city, has been dragged into the mix, with some claiming its ancient technology is zapping ships and planes out of existence. I mean, it's fun to imagine, right? But let's put on our skeptic hats and dig into these ideas. Take the alien theory. It's fueled by stories like Flight 19, where pilots reported strange sights before vanishing. Some say extraterrestrials snatched them up, but there's a problem. There's zero physical evidence. No UFO wreckage, no alien artifacts, just a lot of speculation. Occam's razor, the idea that the simplest explanation is usually the right one, comes in handy here. Is it more likely that aliens are hiding in the Atlantic, or that something more mundane, like human error or bad weather, caused these incidents? Then there's the Atlantis angle. The idea is that the lost city lies beneath the triangle, and its advanced technology, like crystal-powered energy beams, interferes with navigation. It's a cool story, but here's the catch. Archaeologists have found no trace of Atlantis, and the Bermuda Triangle's disappearances don't align with any specific underwater location. Plus, the ocean floor in the triangle has been mapped extensively, and there's no sign of a sunken city. Another popular theory is the time warp or interdimensional portal. This one's a favorite in sci-fi circles, suggesting ships and planes are sucked into another dimension. But again, there's no evidence, no weird energy fields, no confirmed sightings of portals. Most of these theories rely on anecdotal stories, often exaggerated over time. For example, some accounts of Flight 19 claim the pilots saw lights in the sky, but original reports don't mention this. It's like a game of telephone. Stories get bigger and weirder with each retelling. Now, I'm not saying the Bermuda Triangle isn't mysterious. It absolutely is. But the key is to separate the facts from the fiction. Many of the so-called mysterious disappearances have logical explanations when you look closely. Some ships sank in storms, others were lost due to human error, and a few were never in the triangle at all, but got lumped in for dramatic effect. The triangle's reputation as a ship-eating, plane-swallowing monster is partly a creation of sensationalized media. So, if it's not aliens or Atlantis, what is going on? Let's dive into the science. All right, here's where things get really interesting. The Bermuda Triangle isn't just a spooky story. It's a real place with real phenomena that scientists have been studying for decades. Let's break down some of the leading theories that explain why this region might seem so strange. Imagine you're a ship captain sailing through the Bermuda Triangle. The sea is calm, the sky is clear, and then, bam! Your ship starts sinking for no apparent reason. One theory suggests this could be caused by methane gas hydrates, pockets of gas trapped in the ocean floor. When these pockets erupt, they release massive bubbles of methane gas that rise to the surface. These bubbles can lower the water's density, making it less buoyant. Suddenly, your ship isn't floating anymore. It's dropping like a stone. Scientists have found evidence of methane deposits in the triangle's ocean floor, especially near the Blake Ridge. In lab experiments, they've shown that methane eruptions can sink model ships by reducing water density. Could this explain cases like the USS Cyclops? Maybe. The timing would have to be perfect, though, since these eruptions are rare and unpredictable. It's a compelling theory, but it's not the whole story. Next up, let's talk about the Gulf Stream, a massive ocean current that flows right through the Bermuda Triangle. Think of it as a superhighway in the sea, moving water at speeds up to 5.6 miles per hour. That's fast enough to sweep a disabled ship or plane debris far away before anyone can find it. If a ship loses power or a plane crash into the water, the Gulf Stream could carry the wreckage hundreds of miles, making it seem like it vanished without a trace. Take the case of the Carroll A. Deering, a schooner found abandoned in 1921 near the Triangle. No crew, no explanation, just an empty ship. The Gulf Stream could have carried the crew's lifeboats far away, or they could have been swept overboard in a storm. The current's power explains why so many wrecks in the Triangle are never found. Now let's get to one of the creepiest parts: magnetic anomalies. The Bermuda Triangle is one of the few places on Earth where true north and magnetic north align, meaning a compass points directly to the North Pole. Sounds cool, right? But it can mess with navigation. If a pilot or sailor doesn't adjust for this, they could veer off course without realizing it. In the days before GPS, this was a big deal. There's a story about Christopher Columbus himself, who sailed through the Triangle in 1492. His logs describe his compass acting strangely, spinning wildly at times. Was it a magnetic anomaly? Maybe. These anomalies don't suck planes out of the sky, but they could confuse navigators, especially in bad weather. Combine that with the Triangle's vast size, and it's easy to see how someone could get lost. Speaking of weather, the Bermuda Triangle is a meteorological hotspot. It's where warm and cold air masses collide, creating sudden, violent storms. Waterspouts, tornadoes over water, can form out of nowhere, with winds strong enough to tear a ship apart. Then there are white squalls, sudden bursts of wind that can capsize a boat in seconds. Take the case of the Marine Sulphur Queen, a tanker that disappeared in 1963 with 39 crew members. Investigators later found it had a history of structural issues, and a sudden storm could have broken it apart. The triangle's weather is so unpredictable that even modern ships and planes can get caught off guard. Add in the fact that the area is one of the busiest shipping and air routes in the world, and you've got a recipe for accidents that seem mysterious but might just be bad luck. Let's not forget the human factor. Before modern GPS and satellite communication, navigation relied on compasses, maps, and a whole lot of skill. A small mistake could send a ship or plane hundreds of miles off course. In Flight 19, for example, the lead pilot, Lieutenant Charles Taylor, was reportedly disoriented and ignored his crew's suggestions to correct their course. Combine that with faulty radios and a storm, and you've got a tragedy in the making. Technology wasn't foolproof either. Early planes and ships didn't have the advanced radar or weather forecasting we take for granted today. If a storm hit or a compass failed, crews were often on their own. The Triangle's reputation for swallowing vehicles might just be a mix of human error, outdated tech, and the sheer volume of traffic passing through. So, where are we now? Scientists haven't given up on the Bermuda Triangle. They're more curious than ever. Modern technology, like sonar mapping and underwater drones, has given us a clearer picture of the ocean floor. Researchers have found no evidence of alien bases or Atlantis, but they have discovered some fascinating natural features. For example, in 2016, scientists found massive underwater craters off the coast of Norway that could be linked to methane gas eruptions. Similar craters might exist in the Triangle, supporting the methane hydrate theory. Meanwhile, meteorologists are using advanced weather models to study the Triangle's storm patterns, confirming that sudden squalls and waterspouts are more common than we thought. One of the coolest developments is the use of satellite data to track ocean currents and magnetic fields. This has helped debunk the idea that the Triangle is some kind of anomaly zone. Instead, it's a complex region where natural forces, currents, weather, geology, combine to create challenging conditions. The National Oceanic and Atmospheric Administration, NOAA, has even stated that there's no evidence the Triangle is any more dangerous than other busy ocean routes. But the research isn't done. Scientists are still exploring the role of rogue waves, massive, unpredictable waves that can reach 100 feet high. These could explain why some ships disappear without sending a distress signal. And new studies are looking into air bombs, pockets of turbulent air that can down a plane in seconds. The more we learn, the more we realize the Triangle isn't a mystery so much as a natural laboratory for extreme phenomena. So, what have we learned about the Bermuda Triangle? It's not a portal to another dimension, and it's probably not guarded by aliens or sea monsters. Instead, it's a fascinating region where powerful currents, unpredictable weather, and geological quirks create a perfect storm of challenges for ships and planes. Methane gas eruptions, magnetic anomalies, and human error all play a role, amplified by the Triangle's heavy traffic and vast size. But let's be real. The Bermuda Triangle's allure isn't just about science. It's about the stories, the what-ifs, the thrill of the unknown. It's a reminder that our planet still holds secrets, even in a world of GPS and satellites. Whether you're a skeptic or a dreamer, the Triangle invites you to keep exploring, keep questioning, and keep seeking the truth. So, what do you think? Is the Bermuda Triangle just a dangerous patch of ocean, or is there more to the story? Drop your thoughts in the comments, and if you love this deep dive, give us a like and subscribe for more science adventures. Until next time, keep exploring the mysteries of our world.